it's not pretty, but it's a real problem. Do you want to swim in it? Well, you're going to, unless somebody does something about it.
The field trip surprised me in that there's quite a bit of depth in the industry and there's lots of different ways or different ways to do things.
We can turn this stuff into drinking water. We just have to put the right processes in place.
At Palmerston North, the digester has a floating roof. It's not fixed and the gas builds up in there. When we were standing up on top, we could see the sludge oozing out, and there are even tomatoes growing in it.
When we concentrate wastes, we need to concentrate for natural processes to purify them. What we see here is a massive concentration of microbes gobbling up this waste and purifying it.
Treatment plant was quite interesting, the way that put everything in a very small area. It was basically just on the slope of a hillside. They managed to stick a wastewater treatment plant in there, and one of the interesting things they had there was little plastic beads which they used for the activated sludge, so everything was attached to that, and see them all bobbing up and down in the wastewater. It's quite interesting.
Okay, this is how it works. There's good bacteria and there's bad bacteria. Now, although it's not working perfectly here, believe it or not, these are the good guys. 3 kilograms per metre cubed of bacterial culture, gobbling up all the organic pollution. So what about the bad bacteria? The ones that cause disease? Well, here, UV light is used to zap their DNA codes. This essentially kills them off and makes the water safe. % of disease throughout the world can be eliminated through providing clean water and decent sanitation. We can teach you how to do all this. We will provide you with a toolbox of knowledge from which you can develop a solution to any environmental problem.
Basically, each of the different plants that we went to, they had a similar goal, which was just purifying the water, whether it's removing waste or just removing like particles from it to make it drink quality. And yeah, it was just kind of the depth and the ways that they have to go through to purify it. Like some of the plants use chlorine and other plants use like ultraviolet radiation.
I thought it was really good to be able to go out and the lecturers showing us what we might end up doing in industry, and also talking about problems we might face at all plants that ask questions like, what would you have done differently with this plant if you designed it? you'd already known how it was going to go wrong. And it's just those kind of insights. It's quite good to see those.
One of the things ahead, like usually you've got separate processes and it goes to this and it's got a separate tank there, and then the next one separate tank, next one separate tank. There's one bit where they had 2 processes going on in the same tank. And they had sand bed at the bottom which filtered it, and then collecting the sludge off the top. And we got to see them wash out one of the sand beds and get rid of the top stuff as well.
Looking at the Wainuiomata water treatment plant, it really nailed home to me the preciousness of water and the complexity of everything that goes into creating the stuff that comes out the tap. I think at Wainuiomata it was only costing 4 cents a cubic metre for the plant to pump it out, but you could see, I mean, that's because they had relatively clean water because of so-called Clean Green New Zealand. This water, which was seemingly clean as it was coming in, it was straight out of a forested catchment. You know, suddenly they chuck in all these polymers and these flocks just seem to magically appear out of nowhere. And at the end, you know, it showed us that they were filling a skip in a day, basically, with thick brown gunk out of seemingly this crystal clear water. So I think people underestimate how much trouble and time and effort goes into water and all the reticulation systems that go along with it, and underestimate how much money it costs and the preciousness of the water.
Wellington, the council itself is unique because it's the only council that is actually taking sewage sludge and putting it into a composting and returning it back to the land. Most other councils are actually landfilling it. They pipe the sewage, would you believe, all the way to here. It does have problems because of the lay of the land. Once the sludge has been dewatered, it's picked up by hook trucks, a variety of that form, picks up the material, hauls it up in 8 to 9 tonne loads to the composting plant. And we're mixing it up with green waste that is collected from the transfer station. Once the green waste arrives, it goes into the shredding area.
The good thing about this tech paper for me, doing not a technical degree but a planning degree, is that it's quite interesting to see the technical implications for society, basically, and especially in terms of the composting, which we saw today. It's an environmental solution, so to speak, letting nature do its own thing.
It's all about problem solving. Whether it's producing clean water from dirty water, compost from waste, it's all the same toolbox of skills that could see you designing an ice cream factory in the Philippines.
Yeah, dinner last night was quite good actually, yeah.
We want to see you. Come and join us. Technology and Engineering, Massey University.